Okay, this is 4.4, using corresponding parts of congruent triangles. So just one property to add. So we're first going to prove triangles are congruent by one of our 4 triangle congruence postulates or theorems: side, 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 angle, angle, side, angle, or angle, angle, side, and then use that fact to demonstrate that any of the other 3 parts of the triangle not already marked congruent are also congruent. I'm going to start with example 2 here first. It's a little easier, more straightforward than this one. This one has an added step. So if you would go down just to example 2 first. So looking at example 2, we're given in example 2 that angle B is congruent to angle D. I'll just go ahead and mark those. Angle B is congruent to angle D. That's given. We're also given that C bisects AE. Using that fact, that C bisects AE, that puts C as the midpoint of that segment. Therefore, AC is congruent to EC. That's by definition of segment bisector. So far we have, if you look at it, 2 parts here. An angle and a side that is congruent from one triangle to the other. And we're going to get our 3rd part in here to prove the triangles are congruent next. So it says angle 1 is congruent to angle 2. We'll go ahead and mark that. Angle 1 is congruent to angle 2. And we've got the classic bow tie. So the reason for that is vertical angles. And then the triangles are congruent by one of our new postulates or theorems, one of the 3-letter ones. Triangle ABC is congruent to EDC by, if you look at it here, we've got this angle, angle, side congruent to this angle, angle, side over here. So by angle, angle, side, they are congruent. Now, notice that what we're trying to prove has not been marked as congruent already by one of the other properties mentioned in the given, or the fact that you have vertical angles. But because the triangles are congruent, I could say any of the other 3 parts in triangle ABC are congruent to any of the other corresponding 3 parts in triangle EDC. So angle A is congruent to angle E by our new property here, Cpctc. And this first C stands for corresponding. The P is parts. The second C is of congruent triangles. That's what the T is for. R, and then the last C is congruent. That's what that acronym stands for. So you can go ahead and write that out, or you're welcome to use the shortcut, the acronym Cpctc. All right, let's go back up now and look at example 1. So example 1, let me pull these yellow triangles off here. Starts us out looking like that. We're given the following 2 statements. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. It's given. We're going to mark them over here. And, oh, by the way, the hint is to prove that triangle ABC, which is this entire triangle here, is congruent to triangle ADC, which is this entire triangle here. We're given 2 out of the 3 parts we need to prove those 2 yellow triangles congruent. And if we mark them, they are here and here, 1 and 2, and 3, 4. Now, what you see with the yellow triangles is that they share a side, the classic share side case. The side shared is angle AC, or side AC. So we could say AC is congruent to AC by the reflexive property. And therefore the triangles are congruent. Triangle ABC, we're just going with the hint right now, it's in white, is congruent to triangle ADC, and that is by angle, side, angle. Notice that the side is included between the 2 congruent angles. So now we've established that these 2 triangles, the yellow ones, are congruent. Let's pull those off. And now we're going to go ahead and prove that this triangle right here, the upper left one, is congruent to the lower left one here. Now the only thing we can use from the previous three statements is that angle 1 is congruent to angle 2. We can use that. Those are angles that are fully part of not only the two yellow triangles that I pulled off, but the triangles that we're ultimately trying to prove are congruent. Now this single dash line right over here doesn't help us. Go ahead and grab that thing. This thing is referring to AC being congruent to AC. But I can state that CE, I can move this right here, that where it was doesn't help us, but CE is congruent to CE for the same reason that AC was congruent to AC. It's a shared side between the two triangles you're trying to prove are congruent. So number 4, we're going to say CE is congruent to CE by reflexive property. And now I have an angle and a side congruent in each of the two triangles. Now here's where the Cpctc theorem comes in. Notice when this was part of here, this is part of here. These angles over here that I'm erasing right here and over here don't do us any good. They aren't shared, they aren't a part of the triangles I'm actually trying to prove are congruent. But if you'll notice the highlighted sides here, let's highlight a couple of the sides. We've got a side right here and a side right here that are shared between the yellow overlapping triangle, or the yellow triangles that we first proved are congruent, and the blue triangles that I traced that we're ultimately going to prove are congruent. So those sides are shared. They are an entire side in triangle BCE and an entire side in triangle DCE. Pull this off so you can see E. There's E right here. So I can state that CD is congruent to BC using our new property Cpctc. And now I can prove what I was trying to prove for the whole proof. So the triangle BCE, not the little hint part, but the entire proof, is congruent to triangle DCE because of side, angle, side, congruent to side, angle, side. So side, angle, side theorem, and that does it. All right, so our new property is just the Cpctc. Once you prove triangles congruent by one of the 4 congruence postulates or theorems that we've been learning in the first 3 sections, you can then say that any of their other 3 parts are also congruent.